Hello, welcome to the course. My name is Jordan Chrisman and I'm the instructor for this course. And a little bit about myself, I have a lot of FPGA development experience where I've worked with Xilinx as well as Altera FPGAs. And I'm familiar with using both tool sets for each FPGA. Where with Xilinx, I'm familiar with the ISE and Vivado tool, and with Altera, I'm very familiar with the Quartus tool. And in this course, we are going to be using the Vivado tool from Xilinx, which is their newest tool that we'll be using to develop our projects on the RDA7 development board. And for the Altera, we'll be using the DE10 Nano development board, and we'll be using the Quartus design tool to program and implement our designs for the Altera development board. And what is this course about? Well, this course has two main focuses. They are VHDL and FPGA development. So there is a lot to the VHDL language, and so what I'm going to do is go through and explain specific parts of the VHDL language, specifically how it relates to FPGA development. You can use VHDL for a variety of things, but in this course we're going to be focusing on the part of VHDL that's used to implement a design on an FPGA, such as all different types of digital logic or anything else you can think of that you can do digitally. We're going to put on the FPGA, and I'm going to show you how to do just that. So in this course, I'm going to explain how to use the tools such as Vivado, as well as the software development kit for Xilinx, and Quartus, as well as a software development kit used to develop the software processors inside of the Altera FPGAs. And we have two development boards, which I previously mentioned. We're using the DE10 Nano, which is the Altera development board, and the RDA7, which is a Xilinx development board. Now, the layout of this course, we are going to be covering the basics of VHDL, and then we'll work on a project. So you will get some theory and some understanding of how different parts of VHDL work, and then we'll go ahead and do a project. And then we'll cover more theory and a project. So the idea is, once you come to a project, at that point you should know everything you need to know to complete that project successfully. And as I go through the different theory and as I explain them, I will walk through and show how that relates specifically to the next project in the course as they step down. So all of the different projects that we're going to be working with are, we have a buttons and LED project where we are going to press a button on our FPGA board and light up an LED. And the whole idea behind this is we're going to show you how to do the basic, how to take inputs and how to generate outputs. So you're going to have the buttons input and display the output on an LED. And we're going to have a blinky LED project where we're going to show you how to create like a timer, specifically a counter, that we're going to use to take an LED and have it blink on and off at a specified interval. Then we have the LED brightness project, where we are going to go through and vary the brightness of, we have standard LEDs, or if you have the RDA7 development board, we have standard as well as an RGB or a red, green, blue LED. And in this project, we are going to vary the brightness, which we'll be using a pulse width modulation. So I'm going to explain how pulse width modulation works, as well as how to take that concept and implement that design in VHDL, and then take it and actually put it on the development board to vary the brightness of the LEDs they have on the board. We then have a UART demonstration project, where this is just a very basic showing you how to use UART on your development board. Both boards have a UART port, and this is just going to show you how can I take information that's being on the actual development board and how can I display it on my computer. Well, you can use the UART port to take that information and display it on the computer, so we're going to show you how to do that. And then we have the UART I/O project, where we are going to take information just like we did in the UART demonstration project, but take it a step further, where we are going to take inputs in. So we'll type in commands on our computer to make certain actions occur on the development board, such as read the input and tell me which buttons are pushed or which switches are high, and also send a command to tell it to light up certain LEDs. We have an AD processing project where we are going to interface both boards with a temperature sensor, and I'll show you how this works by doing the analog to digital conversion. and we're going to have the variance of temperature. So we'll make the temperature sensor go cold and show that, okay, as the temperature sensor gets colder, you'll see the temperature go down, and as the temperature sensor gets hotter, the temperature will go up. And we're going to take that temperature, and so we'll calculate both the Celsius and Fahrenheit temperature and then display it on the computer screen so that you can see the actual ambient temperature or the temperature that the sensor is indicating. And then we have a SPI interface project. This project is going to only be working with the ARTI A7 development board. And what we'll do is we're going to take and store information on the onboard SPI flash. And this is because FPGAs are volatile memory, which just means you program the FPGA and you power it off and power it back on, the configuration is lost. So we're going to show you how to take information and store it on the external flash so that when you power back on and reprogram the FPGA, you can pull that information from the external flash. So we're going to work on and show you how to do the interface between an FPGA and external flash using the SPI or SPI interface. And then we have for the final project is the I2C interface project. And in this project, it is only going to be working with the Altera DE10 Nano development board. And we're going to use the I2C interface to talk to a G sensor or an accelerometer that is on the DE10 Nano board to tell us different things such as the position of the board as well as the amount of gravity sensed by each of the three axes. And then we'll take that information and display it on the computer through the UART port as well. And so those are all the projects that we're going to cover in this course. And who is this course for? This is for anyone who has no previous FPGA or VHDL design experience and wants to understand how it's used as well as implement a design from scratch on FPGA. So whether you're an engineer, student, or hobbyist, this course is specifically designed for you to show you how to do this type of project and use FPGAs. Now that you know what to expect from this course, let's get started.